Here we are going to solve the recurrence relation. Equation is given an minus 2an minus 1 equal to n plus 5, and the boundary conditions are given n is greater than or equal to 1 where the value of a0 is 4. Step first is to find the auxiliary equation. So I can easily observe its auxiliary equation, and I will write r square minus 2r equal to 0. Here I am putting an equal to r raised to n and n equal to 2. So the equation will become r square minus 2r. R is getting common, and the equation will become r minus 2. Now r equal to 0 or r equal to 2. So we are getting first root r equal to 2. So it's homogeneous equation. Step number 2, we have to find the homogeneous equation is a and h equal to c1. Since it is only one root, so we are writing here c1 into r raised to n. I'll write the value of c1, r is 2. So this will be our equation number 1. Now we have to find the value of c, but before that the particular equation is there, a and p. So we'll replace our equation with this value an minus 2 an minus 1 equal to n plus 5. This equation we will replace with these values, and we'll find the constant a0 plus a1 n. Here n is there, so we are putting n, but 2 multiplied by an minus 1. So here a0 plus a1 into n minus 1 and n plus 5 as it is. So we will solve this equation. Here we are getting the equation a0 plus a1n minus 2a0 minus 2a1n plus 2a1 equal to n plus 5. We are taking common terms a0 at one side. a0 minus 2a0 will be minus a0, and minus this a1n and minus 2a1n will be minus a1n plus 2a1 as it is equal to n plus 5. Now compare the term n terms and constant terms. Here two constant terms are there, minus a0 plus 2a1 equal to 5, and only one minus a1 equal to the coefficient of n is only 1. So a1 will be minus 1. Putting this minus 1 in our equation, we are getting minus a0 plus 2 multiplied by minus 1 will be minus 2, and that is equal to 5. So easily these two will be on right side will become 7, and this a0 is negative, so a0 will be minus 7. So we are getting two constant as a0 equal to minus 7 and a1 equal to minus 1. So putting this equation in our particular equation, this a and p, we are getting a0 plus a1n, that is a0 is minus 7 minus 1 into n, that is minus, I will take common n at this side, n plus 7. Solution an total will be an h plus an p. An h we are getting c1 into 2 raised to n plus here I am getting minus, so I will get minus n plus 7, and a and t. We have the boundary condition n is greater than or equal to 1. For that value a0 equal to 4. If we put n equal to 1, then we don't have the value of a1n. So again I am writing the previous equation that given in our problem to find a1, value of a1. So put now n equal to 1, because they have given us n equal to 1. So I will get a1 minus 2 a, 1 minus 1 is a 0, and again n equal to 1, so 1 plus 5. We have a0, value of a0 is 4, so a1 minus 2 into 4 equal to 6. This value is, so we are getting 6 and this minus will be plus here. Please plus it. A0, sorry, A1. Now this value will put in our equation. A1 equal to C1 2 raised to 1 minus n is what, 1 plus 7. A1 is 14 when this n equal to 1. C1 into 2, 2 raised to 1 is 2 and 8. So 14, this minus 8 will become plus at this side, C1 into 2. So C1 I will write it this side, and this 2 is a multiplied, so it will 14 plus 2 is 22 divided by 2. So we are getting C1 equal to 11. So our solution will be AN total equal to ANH plus ANP, and A1 value of C1 is 11 into 2 raised to n. Get again 11 into 2 raised to n minus n plus 7.